Hello everybody and welcome to day 4 of the Edyst daily challenges. That the challenges are over of June 2021 and I hope you enjoyed it, and if you did, please hit the subscribe button to get to know more about such challenges. Do hit the like button as well, so that other people can find this, and share these challenges with anybody who you know might benefit from it. We did it so that you come to know the level of some product companies, what are the questions they ask, and so on. Today I'm going to be doing two things: announcing the winner of day 4, also announcing a very special announcement about the algos and data structures batch that we're launching out. And yeah, that's pretty much it. So we'll get started now. This day 4 challenges has been going on, and we finally have a winner for the Amazon Eco Dot that we were talking about. But before that, a quick announcement on the algos and data structures batch, the DSA batch that Edyst is announcing. It's a batch that starts on the 19th of June. It is a paid batch because you get direct interface with me and Devang, instructors of yours for this course. And not only that, we have guided students into product based companies like ServiceNow, Zenoti, Google, Adobe, JP Morgan, where alumni are earning anywhere from 10 lakhs per annum up to 45 lakhs per annum. Yes, I'm not joking, that's exactly the number. We are going to release the interview experiences of all these alumni slowly on our YouTube channel, so do subscribe to the channel for that. But yes, if you are somebody who has been doing the daily challenges, is finally able to solve the problems. You may not be the first person to solve the problem, but you're finally able to solve the problem somehow. Then you have what it takes to actually aim for a product-based company. And we want to help you reach those product-based companies level. And this is one such batch where you get doubt clearing sessions, you get mentor support, and you also get one-on-one time with Devang and me to actually clear your doubts and explain concepts. So yeah, do sign up for this course whenever you can. The seats are closing in pretty fast, so sign up and join us for this amazing ride where you will get tutorials and live classes on all of the topics like dynamic programming, graphs, backtracking, or even the basic topics. And depending on your profile, we will also refer you to some product based companies as well. Okay, so yeah, this is just one thing I wanted to let you know. You can find the link in the description below. Now coming to today's the day 4 challenge, basically, just to let everybody know, somebody who's watching new, we have from 8th June to 11th June we ran a few challenges. The challenges are now over, but they are still available on the Edyst platform. You can go ahead and try them out. Definitely, the link for that is also in the description. The prizes to be won were these. So on day 1 and day 2 we were giving out Boatstone speakers, both of them won by Chitresh. Day 3 we gave out the MI Smart Band, won by Raghavendra. And day 4 we have given out the Eco Dot. And who has won the Eco Dot? Well, none other than Bhagati Jogarao. He's been one of the most regular students on Edyst. He's won a few daily challenges last year as well in 2020, and we're glad to have Bhagati win it in 2021 as well. So congratulations, the Amazon Eco Dot is all yours. The person to win the JBL headphones, the random prize winner. So everybody, we also are giving out random prizes to somebody who's just participated. Whether or not they cracked the question is a different story, but just for participating, we've given a random prize. And Kishore Anand is the one who's got that. So congratulations to you, Kishore, for getting a pair of JBL headphones. Now let's actually go to the question at hand. The question that was day 4 question, which was called as battle score. So the question's name is battle score, and the question actually just boils down to this: you have two armies battling, and what's happening is that one army is characterized by A and B, two integers A and B, and another army is characterized by C and D. All right, so you have all these armies battling, and what you have to find is the score being every number in the range A to B will XOR with each number in the range C to D. So finally what you have to do is you have to go from A to B, and each number in A to B you have to XOR with each number in C to D. Okay, so how many pairs will you have? You will have all the numbers in A to B being XORed with all the numbers in C to D, right? So you're actually going to have A, B, C, D a pair, sorry, B minus A into D minus C pairs. Okay, I'll come to that in a bit. And so once you've XORed all of these, you have to also sum up the number of the XOR of each of these XOR operations and give the answer for that. So that total sum is your actual answer. Okay. Now, and since the sum can be used, you have to return it output modulo 10 raised to 9 plus 7. That's a standard ask that's there. Now, first of all, these numbers are huge. So 10 raised to 9 directly. Like, even if you think that you can go from A to B in 10 raised to 9, let's say both like A is 1 and B is 10 raised to 9. You can't even run a for loop in that much. Why? Because as I've told you all earlier that you can generally do about 1,000,000 iterations. So that's 10 raised to 6, but you can't really do anything more than that. This is on the top of it, just to go from A to B, it might just be 10 raised to 9. And imagine on top of that, you have to multiply with each number from C to D. So this could actually go 10 raised to 18. So this is where, this is the training, we do in the bootcamp as well, that what we try to do is, the moment you see these constraints, your mind should start thinking, hey, I am not supposed to go from A to B, let alone multiply each number from A to B to C, with C to D, right? Forget even multiplying, you're not even supposed to go from A to B. There has to be a better solution over here than going from A to B. So that's your first hint, and that's what you have to start thinking. Combined with the fact that it's an XOR means it's a bit manipulation question. Okay, there is no DP involved here, none of that. It's just a simple, straightforward bit manipulation question. And for those of you who are wondering where this question has come from, well, all the questions that we have taken are all previously asked questions only. This is a previously asked question of Uber, where if you would have solved this, you could have gone to the next round for an 18 lakhs per annum package, right? So yeah, that's our philosophy. We try to give you previously asked questions. We're not giving you theoretical questions. These are questions that are genuinely asked earlier. All right, cool. So for example, if you have 1, 2, 3, 4, then I will take all the numbers from 1 to 2 and XOR them with the numbers in 3 to 4. So for example, I'll do 1 XOR 3, 1 XOR 4, and then 2 XOR 3 and 2 XOR 4, and the sum of all of those I'm going to add up. So 1 XOR 3 is 2, 1 XOR 4 is 5, 2 XOR 3 is 1, 2 XOR 4 is 6. So when you add up all of this, you get 14. And you can try out these XOR on your own and you'll get the similar answer. Okay. All right. So how do we actually solve this question? Well, to even get the intuition of how to solve this question, we need to first come to a few simple mental models or few understanding of how to solve bit manipulation questions. Okay. And I'm giving you a very brief over here, but this is in itself a good 2 hours, 3 hours lecture that we do in our Algos and Data Structures Bootcamp. But the mental model for any bit manipulation question is always try to think each bits in terms of, or each number in terms of bits. Okay. Before we even come to XORing and so on, let me just show you. Whenever there's a bit manipulation, when there's a range of numbers in bit manipulation, my mind automatically goes to something like this. So over here, let's say I have to display all the numbers from 0 to 15. I stop thinking of each of the numbers as a horizontal set of bits, which is 0 is all zeros, 1 is 0, 0, 0, 0, 1, 2 is 0, 0, 0, 1, 0, then 3 0, 0, 0, 1, 1. I stop thinking in terms of this horizontal and I start thinking vertically. What do I mean by vertically? If you look at the bit 0, okay, it has these bits from 0 up until 15, including 15 and including 0. The 0th bit, the least significant bit, starts, these are the bit values. Okay, and you can see there's some pattern over there. I'll come to that pattern, but these are the values for it. For the 1th bit, excuse me, for the 1th bit, you have 0, 0, 1, 1, 0, 0, 1, 1. Again, there's a pattern, but more importantly, you have to notice the bits like this. Same thing with 2, you notice the bits like that, 3 and 4. And so each bit, you start noticing it in a particular way. This is the first observation that you should make, and always especially when there are ranges involved in bit manipulation, this is the first place where you should go, and this is the first place where your intuition should start building. So that's number one. That's the mental model for a bit manipulation question. The second thing is, how can I find the number of set bits between two numbers in constant time? Now you'll say, what has that got to do with our question? Again, it's not that what it's got to do with our question. It's a useful technique that had you known that technique, you would have immediately solved this. So it's a technique, just like many of the important techniques in Algos data structures, it's a technique you should know in your head. So I'm just trying to show you that technique right now. The technique is as follows. I'm just giving you a hint of that technique, a gist of it, because again, as I said, it in itself is a good 2-3 hour lecture. All right. The technique goes like this. What I'm trying to ask is, between 3 and 13, both inclusive, how many set bits will I have? And very specifically, I mean, what do I mean by set bits? See, like over here, what I'm trying to say is between 3 and 13. So the 5th bit is never set between 3 and 13. When I say set, I mean it's never 1. Okay, it's never a set bit, it's always unset. The 4th bit is never set over here, but the 3rd bit is set sometimes between 3 and 13, both inclusive. So this bit is set 6 times. Okay, if you can just count it, 1, 2, 3, 4, 5, 6. So 6 times this bit is set. Okay, that's 6 times over here. What about the second bit? The second bit is set another 6 times itself. So 1, 2, 3, 4, 5 and 6. So it's set another 6 times by itself. Okay. And what about the first bit, the 1th bit? The 1th bit is set 5 times. So it's set 5 times. And the third bit, the 0th bit is set 6 times again. So it also is set 6 times. Okay. This is set 6 times. So totally speaking, between 3 and 13, how many set bits do you have? You have a total of 23 set bits. If you start counting between 3 and 13, how many set bits you have? You have a total of 23 set bits. Okay. If you want, you can look at it this way also. 2 set bits here, 3 set bits here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I think I missed one bit somewhere because we should have 23. Let me have a look at it again. 1 second. Let's start again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I had missed one significant bit over there. But overall, you have 23 set bits between 3 and 13, both inclusive. Okay. Now, one way of calculating this is by going through each number horizontally, which is what I said not to do, right? You can go through each number and figure out in 3 I have 2 set bits, in 4 I have 1 set bit, in 5 I have 2 set bits. You could do this, but as I said, that's not the advisable approach because you will have to visit each number from 3 to 13. Rather, if you notice a pattern, you will start noticing a pattern that the 0th bit actually alternates with 0, 1, 0, 1, 0, 1, 0, 1 all the time. Okay. So you will get a cool pattern over here where you can realize how many ones should be set between 3 and 13 in the 0th bit, which we are saying is 6. Okay. Similarly, on the 1th bit, I can also check how many are there simply by observing the pattern. Because I'm always going to have the bits going 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. I can very easily find out between 0 and 13 how many 0, 0, 1, 1, 0, 0, 1, 1 came. Between 0 and 3, how many 0, 0, 1, 1 had come, and I can subtract them. Okay, I repeat, because of observing the pattern and each bit is repeating in a certain pattern way, I can figure out between any two numbers for each bit how many set bits are there. I can figure out that there are 5 set bits in the 1th bit position, 6 set bits in the 2th bit position, 6 set bits in the 3th bit position, and so on. I can figure this out simply by observing the pattern. Now, how do I do that? This I will leave up to you. Try to implement this part. The moment you implement this, and the way you would implement this is find out between 0 and 13 how many are the set bits, find out between 0 and 2 how many are the set bits, and subtract them. So from 0 till 13 you can find out how, because you know from 0 till 13 each bit itself is having a particular pattern. 0 1 0 1 0 1 0 1 0 0 1 1 0 0 1 1 4 zeros 4 ones 8 zeros 8 ones and so on. So you can find a particular pattern. This in itself is a question asked by Hack with Infi for a 7 lakhs package. Just this part. Okay. So if you figure out this yourself, this itself will give you a correct answer for another company's question itself. Now, the point here being that you need to do this only for each bit. Like how we did it, we figured out for 6, we figured out for the 3rd bit, 2nd bit, 1st bit, and the 0th bit. Anything beyond that is just zeros. If I do this for each bit, I can figure out how many are the set bits for each bit position, not for each number. So you could do from 3 to 13, you could do from 3 to 100, 3 to 1 million. It won't matter, because all I'm trying to figure out is for each bit how many 00s and 11s will be there, which is a mathematical formula. It has nothing to do with running a for loop. I don't have to go from the 0th bit all the way up till like 1 million and figure out. I don't have to do that. You will already be able to figure out between 0 and 1 million how many 00 and 11 will be there. You will be able to do that for each bit position. So then the number of bits, the actual number of bits between 2 points, the number of set bits between two numbers in constant time is possible. Again, I leave it up to you how to actually implement that, but you can go ahead and implement it, and that will really help you out. So this is a prerequisite. You should have known this, right? If you want to play in the big leagues and you want to go for bit manipulation questions, this is a pattern that you should observe, and you should have already known this. Okay. All right. The second thing is how can I actually find the sum between two numbers based on number of set bits. All right. So one of the ways of finding the sum of numbers, let's say if I tell you, can you find the sum between n and 3 and 13, the sum of all the numbers? One is you can just use the AP formula. You can also use a sum of natural numbers up till 13 minus sum of natural numbers up till 3. There are many ways. Another way that you could do is you can say, hey, if I do sum up all of these, I will get, I'm going to actually sum up 6 bits in this position, which is nothing but what is 2 raised to 0? 2 raised to 0 is 1 itself, right? 2 raised to 1 is 2 itself, right? So I'm going to say this is 2, and you'll think what's going on here. I'll just tell you in a bit. So what we're trying to say is the final number that you get is nothing but 6 into 8 plus 6 into 4 plus 5 into 2 plus 6 into 1. What do I mean by final number? Take the sum of all the numbers between 3 and 13. The sum ideally should be 88. Okay, the sum is going to be 88. If you take 3 plus 4 plus 5 plus 6 and so on, you'll get 88 as the sum. Well, I can get the same sum by, if I know the set bits between these two, like how many are the set bits, I can also get the same sum. Let me just show it to you. So let's say, for example, I multiply 1 into 6. I'll get 6. Here I'll get 10. Here I'll get 24. This so far is 40. And how is it 40? 24 plus 10, 34 plus 6, 40. And this is again 48. So if I take the sum of this, I get 48, which is the same thing as taking the sum between 3 and 13. It's not magic. All we have done is we've taken the coefficients of the power of 2 and we've just added them. That's all we have done, right? So this is another thing that you should know, which is basically, if I just sum up all the numbers, it's like if I had all the set bits and multiplied them into the powers of at their respective position, I would get the same sum as if I had a sum between 3 to 13. Okay. Now, why is this important? This is important because let's say, for example, you had a bunch of numbers which are not consecutive. Let's say you had a bunch of numbers which are not consecutive. Let's say you had 1 0 1 1, you had 0 1 1, and you had 1 0 1. None of these are consecutive, right? None of these are actually consecutive. But what you could do is, that at the first, the least significant bit position, I have 3 set bits. So I can say that it's 3 into 2 raised to 0, which is 1. Okay. At the second position, I have 2 set bits. So I can say it's 2 into 2, right? And at the third significant position, I have only 1 set bit, which is 1 into 4 plus the most significant bit position. Again, I have only 1 set bit, 1 into 8, which will come to 12 plus 4 plus 3, which is equal to 17, right? No, it's not equal to 17, it's 19. This will be 19, which again, if you had added this, you would have got 1011 is 11 plus 3 plus 5, right? This is also again 19, right? So both of these will give you the same answer. But my point is, if I know how many are the set bits in a particular bit position, I can just multiply it by power of 2, and that also gives me the answer. So now that we have these ingredients, these were just ingredients, by the way. Now that we have these ingredients, now let's come to the question. How has all of these got anything to do with finding the XOR between 2 ranges, right? And multiplying the XOR and so on, okay? So what it's given to us is, go from A to B and XOR with all numbers from C to D, right? That's what we need to do, okay? And so, for example, I have A1, let's call it like, A1, A2, A3, so on up until AN, let's say, and you have your C1, C2, C3 all the way up until CN, where CN and AN are like, CN is D, AN is B, right? So it won't be AN particularly, this let's say be or CN, this let's call it CK, because I'm not saying that the numbers are equal. A and B can be a very big range, C and D can be a very small range. One of the properties of XOR is that A1, what do I need to do? A1 XOR C1 plus A1 XOR C2 plus so on. This I need to do. You can also consider this as C1 XOR A1 plus C1 XOR C2 XOR A1 and so on. Basically saying that A XOR B is the same as B XOR C. A XOR B is the same as B XOR A. It can be reversed. So just for you all to know this. Now what I'm going to do is, I'm going to go through each number in A to B and XOR it with C to D. As I said, whenever you have ranges, try to figure out what effect that has on the range. Okay, so let's just go back to our representation and just try to figure out what effect that will have on the range. Let's say the C itself, the C that you have, let's say it's a number like this. So I'll again represent it in something like this. But let's say the C to D is something like this, where you're starting from 1 triple 1, let's say 001, and you're going from the next number would be 1010, 1010. Then the next number is going to be 1011, and then the number after that is going to be 1100, right? These are the numbers. What is 1001? It's nothing but 9. So you have 9 over here, let's say. So what I got was 9, 10, 11 and 12. That's basically, I said, take the numbers 9, 10, 11 and 12, and A to B is 3 to 13. So 9 to 12 is being XORed with all the numbers with 3 to 13. Okay, all right. Let's only observe 9 for now. Let's only observe 9 for now, and let's go with all the other numbers. What is 9 going to do? What 9 is going to do is, let's again consider each bit. This 0th bit is 1. When I XOR it with all the numbers with 3 to 13, wherever the 0th bit was 0, it's going to become 1. Wherever it was 1, it's going to become 0. Because that's what this XOR with 1 will do, right? XOR with 1 is going to make sure that if it's a 1 XOR 1, it's going to make it 0. And if it's a 0 XOR 1, it's going to make it a 1. So it's basically going to flip the bit. This 1 will become 0, this 0 will become 1. So it's just going to flip the bit. So the number, so that's what this 1 is going to do. Let's just take that for example. What is the 0 going to do? If there was a 0, it will show that it is still 0. If there was a 1, it's going to flip it. Okay, if there's a 1, it's actually going to convert it to a 0 over there, right? No, it's not going to. Sorry, it's not going to convert to 0. It's going to make it same. So 0 will preserve the value. 0 XOR 0 will be 0. 1 XOR 0 will be 1 only. So the 0 is going to preserve the value. 0 is not going to change anything over there. So what's going to happen at the end of this is that between 3 and 13, what did we say? We had 6 set bits, right? Over here. And how many are the numbers between 3 and 13? Between 3 and 13, you actually have 11 numbers. If you count 13 minus 3 plus 1, you're counting 3 as well. So you have 11 numbers. So when you XOR all those numbers with just 9, each of the numbers being XORed with 9, in the 0th bit, all of the 1s will shift to 0 and all of the 0 will shift to 1. Because I am XORing with 1 over here. All of the 1s will shift to 0 and all of the 0s will shift to 1. So I had 6 set bits. Now they will become 5 set bits when I XOR with 9. Why? Because I have 11 numbers. I had 6 set bits, but they all flip to 0 and all the 0s flip to 1. When I'm XORing with 0, I will preserve the previous 5 bits that I had, right? Because XORing with 0, if 0 XORed with 0 will still give me 0. 1 XORed with 0, it will continue to be 1. So they will just preserve. Same thing with 2 will preserve. Now comes to 3. I had 6 set bits earlier in this position. Now it's going to become 5 set bits. Why will it become 5 set bits? It's going to become 5 set bits because I had 6 numbers earlier. All of those flipped and the remaining 5 zeros flipped to 6. Okay. The remaining 5 zeros flipped to being ones. So now we have 5 ones, and all the 6 zeros that we had, 6 ones we had, have now become zeros. Okay. So now if I had to just do 3 XOR 9 plus 4 XOR 9 plus 5 XOR 9 all the way up to 13 XOR 9, what I'll actually going to get is, this is how the number of set bits will change, which means that value is now going to be, the sum, if I had to take it, is going to be 5 into 1 plus 5 into 2, 10, plus 6 into 4, 24, plus 5 into 8, 40, right? Which the entire sum comes out to be, if we do the quick calculation, it comes out to be 79. 40 plus 24, 64, 74, 79. How did I do this? I did not actually do XOR with each value. Simply, I found the number of set bits between 3 and 13. And I realized finding number of set bits between 3 and 13 was simple. It was just, I have to go through each bit position, which is a constant set of bits. It's a 32-bit integer or a 64-bit integer. Be it 3 to 13, be it 3 to 1 million, I already know for each bit position how many set bits are there. And I know if they are to be XORed with 9, how they are going to change. Or XOR with anything else, I am going to change. How? Because I can go through each bit of that number also and figure out where I have a 1, where I have a 0. Wherever I have a 1, flip it. flip the number of bits that I had, and when I have a 0, preserve it. Don't change it. This is just for the 9. Now I'll have to do the same thing for 10, for 11, for 12. Okay. Now you might be thinking, but sir, even C to D can go up to 10 raised to 9. So even C to D, I cannot go from 9 to 12 is fine, only 4 numbers. But let's say 9 to 10 was a million, or 10 million, or a billion, let's say. Then how are you going to go? Exactly. Even from 9 to 12, you don't need to go. Why? Because what you need to find out is between 9 to 12, how many set bits are there? And that's again easy to find out. That's the first thing that we talked in this tutorial. If I find out between 9 to 12 how many set bits are there, so just to give you an example, if I find out, okay, between 9 to 12 I have on this bit position I have 4 set bits, right? Here I have 1 set bit, here I have 2 set bits, here I have 2 set bits. So it's 4, 1, 2, 2. So what's going to happen here is, here 2 times we are going to have a flipping. 2 times we are going to have a flipping over here. Okay. And 2 times we are going to have the same value preserved, whatever was the original value. Similarly, here also 2 times we are going to flip, 2 times we are going to have the same value. Here 1 time we are going to flip, the other 3 times we are going to preserve the same value. And here 4 times we are going to flip it completely. Okay. So now I figured out how many times I have to use the original bit set bits and how many times I have to use the flipped set bits without traversing from 9 to 12 and without traversing from 3 to 13. The number of times I have to flip, I got in order 1. The number of times the number of bits that I should flip or not flip, I got in order 1, right? That's the first thing that we covered. So if, again going back, if you had known this pattern, that's the first pattern. If you had come to know this one, this one over here, finding the number of set bits, if you had known this in constant time, then you can apply it to both C to D as well as to A to B, and your actually entire program comes in constant time. The first hint for that was in our constraints, which was it goes up to 10 raised to 9. Okay, so what you're going to do is just to give you an approach, and the solution is available on the Edyst platform. You can check it out there. Approach: find for each bit, find number of set bits from A to B. Then what you're going to do is, for each bit, find number of set bits from C to D. And what you're going to do is, you say where C, or let's say number of set bits is, let's say K, we'll call it K. Okay. So what I'm going to do, or we'll also call it as, let's say we'll call it as X over here, and we'll call this as Y. So what it finally comes down to is, for those Y bits, for these Y set bits, that particular, for each bit. So again, I'm doing this for each bit. Okay. For each bit, what I'm trying to do is, for those Y set bits, I will flip the ones in X. So I'm going to say, for these Y set bits, the number of set bits you'll finally get is Y into B minus A plus 1, which is the range, right, into X. Okay. No, wait, it's B minus A plus 1, not into X, minus X. Why minus X? X were the initial set bits. I want to flip it, which means take the remaining part of the range and remove X from that. So you flipped it. So this is Y into that. Plus, in the case of non-set bits, so when you're preserving, so when Y, C to D means Y is set. When is Y unset, or when is those C to D 0? That is nothing but D minus C plus 1 minus Y. In all of these cases, I will multiply into X directly. Okay. Now, for a particular bit, this is how many set bits I am going to have in my final answer. And as we discussed, if I know the number of set bits in my final answer, I can find out the sum also, right? I can actually end up finding the sum as well. So this is for this bit. So let's say this for the 0th bit. So you'll raise, 2 raised to 0 into whatever is, this is the coefficient. Then you'll do the same thing for 2 raised to 1. Then you'll do the same thing for 2 raised to 2, and so on. So this is for each bit. You'll get the final one, that you'll get the final solution, or basically you'll get a configuration like this, that is something like, for for the let's say 32th bit, 31st bit, 30th bit, 29th bit, all the way up until 3, 2 and 1. You'll get something like, okay, when it comes to the first bit is set, let's say 15 times. The second bit is set, let's say 6 times. The third bit is set, let's say some 20 times, whatever it is, right? Then what you'll do is you'll finally multiply, okay, 1 into 15 plus 2 raised to 2, 4 into 6 plus 2 raised to 3, 8 into 20 and so on. You're going to multiply that, and that sum is going to be your final answer. I hope I've been able to convey the intuition of this to you. As I said at the start of this tutorial, generally speaking, talking about the entire pattern itself is a good 2-hour lecture, but just trying to speed it up over here so that you all know. For more such interesting patterns that you want to find out and you want to be ready with, so that in any coding round you're ready with it, do check out our Algos and Data Structures Bootcamp, which is launching. We are launching it almost every 2 months. So the June 2021 is launching pretty soon. So go ahead and check that out. And yeah, try out this problem. The solution is available on the Edyst platform. So I really hope all of you enjoyed the June 2021 daily challenges. Let us know if you would like to continue these daily challenges in the comments below, and what improvements you would like us to do, what help you need in your preparation. Do let us know in the comments and description in the comments below. And yeah, all the links are in the description below. Thanks all for joining in today, and I'll catch you all next time. All the best, stay safe, and happy coding to all of you. Thank you.